We all see the promise of 8K resolution. It's incredible. But the physics of actually getting that signal from a source to a display,
Oh, especially across a room.
it's a nightmare. I mean, you're trying to push, what is it, 32.4 gigabits per second?
Exactly. And on a standard copper cable, electricity just, well, it gives up. Resistance kills it after just a few meters.
And that's that cliff effect people talk about, right?
That's the one. You buy a super expensive 8K monitor, run a 50-foot copper cable, and you just get a black screen. The signal attenuation is just too high.
Which brings us perfectly to the hardware for today's deep dive. We're looking at an active optical cable from NTI.
The DP8K series.
Right, and the whole mission here is to solve that exact distance problem. This is a 25-meter cable that claims 0 signal loss.
And the way they do it is really the interesting part. It's not just more copper.
No, they call it a hybrid architecture.
And that distinction is so key. I mean, think about it. Pure fiber is fantastic for data, but it can't carry any power. And pure copper carries power just fine, but it chokes on that much data over any real distance.
But this cable uses both.
Precisely. It uses 4 optical fibers just for the heavy lifting, the high-speed video, and then it uses copper cores for the low-speed signals and for power.
It's like using photons for the data highway and electrons for the utility work.
That's a great way to put it. And by offloading that video data to fiber, you completely bypass electromagnetic interference.
Which is a huge deal in noisy environments.
Oh, absolutely. In a factory or a broadcast station, a long copper wire is basically a giant antenna, just soaking up all that RFI and EMI noise. The glass core in this is totally immune.
What really stood out to me in the specs, though, was the power. Usually you see active cable, and you just sigh.
Yeah, because you have to find a USB port somewhere to plug in a power adapter.
Exactly. But not this one.
No, and that's the elegance of the hybrid design. It's drawing all its power directly from the DisplayPort interface itself.
So from the source device.
Yep. From pin 20, via those copper cores we mentioned, it's just enough to power the little electro-optical conversion chips right inside the connector heads.
So it's completely plug and play, even though it's this complex active optical system.
It is.
And we should probably underscore what that 32.4 GBps of bandwidth actually gets you. This isn't just for a static desktop wallpaper.
No, not at all. This is full Ultra HD 8K at 60 Hz. Or, for gamers and high-motion work, it's 4K at 120 Hz.
Even 1080p at 240 Hz.
Right. It's total overkill for a spreadsheet, but then you look at the use cases they list in the documentation, they highlight medical imaging.
And that is such a high-stakes environment.
Totally. If you're a surgeon looking at an 8K display during a procedure, you simply cannot have signal flicker or artifacts.
So 0 signal loss isn't a marketing buzzword there. It's a genuine safety requirement.
It absolutely is. Same for, say, digital signage in an airport or onboard video systems on an airplane. These things have to be reliable.
They even list the operating temperature range from -40 to 158 degrees Fahrenheit.
So you could run this through an uninsulated attic in Phoenix or inside a commercial freezer, and the glass core just doesn't care.
But there is one major gotcha with these active cables that can really trip people up.
Oh, yeah.
It is strictly directional.
And it happens all the time. You spend an hour carefully snaking the cable through a wall or a conduit, you get it all perfect.
And you realize you plugged the source end into the monitor.
Exactly. Since those chips are specialized, one end encodes, the other decodes. If you reverse it, you get absolutely nothing.
A painful lesson. So you definitely want to double-check the labels on the connectors before you start routing it.
Please do.
But physically, for a cable with fiber in it, it's pretty workable. It's only about 5 millimeters thick.
Yeah, and the bend radius is just 20 millimeters. It really dispels that old myth that fiber is super fragile and you can't bend it. This is designed to be routed.
It all just highlights that as our displays demand higher and higher resolutions, the invisible infrastructure has to change with it.
It has to. We can't just keep making copper wires thicker. We have pretty much hit the physical limits of copper for this kind of work.
So for the future of high-fidelity video, the pipeline has to be light.
It really does.
So a final thought for you to consider. Next time you're troubleshooting a flickering high-res display and you're blaming the monitor or the graphics card, maybe ask yourself, is the real bottleneck the screen, or is it the simple wire you're trying to force all that data through?
That's it for this deep dive. Thanks for listening.